Hello. Today we're going to talk about solving inequalities. Now, inequalities are the less than, greater than, less than or equal to, or greater than symbols. But before we do this, I want to refer back to what we already know about solving equations in general. Given the equation 2x equals 6, most of us will look at this and say, okay, what I need to do is divide by 2 on both sides. Divide by 2 leaves us an x equals 3. Okay, pretty straightforward, pretty simple. When you're solving inequalities, even though you don't have an equal sign, all the rules still apply. So instead of having an equal sign, we use the inequality and it works the same. So if I have 2x is less than 6, I'll still divide by 2 on both sides, and I'm left with x is smaller than 6 divided by 2 is 3. So very similar. In fact, adding and subtracting, the sign always stays facing the same direction. Nothing changes. There's only one major thing that you need to know, and that is what happens if you multiply or divide by a negative number. So if I have a negative 2x is smaller than or equal to 6, then I'm still going to divide by a negative 2, just like I normally would in a regular, whether it's an equal sign or not. And the negative cancels the negative, 2 cancels the 2, and you're left with nothing but x. But what happens is this sign, this less than sign, changes to a greater sign, and only because it has this negative 2 on the bottom, on both sides. So if you divide by a negative value, it switches the sign. So 6 divided by negative 2 is a negative 3. So if you're multiplying times a negative, if you're dividing by a negative, make sure you flip the sign. If you divide by a positive, such as here, the sign will always stay the same. Again, adding and subtracting, the sign stays the same. Only multiplying or dividing by a negative flips the sign. Now the next thing that's often talked about in these sections are set builder notation, or graphing these equations. If you ever go and need to graph these equations, we're not talking a coordinate grid, we're just talking a simple number line. So for the first one, x is smaller than 3. Notice how x cannot be 3 because x has to be smaller than 3. So we'll go up to 3, we'll leave an open circle at 3, and we'll shade smaller than that. And we're going to put an arrow. And the arrow means it goes on forever. Now, if I'm shading, if I'm going to graph x is greater than or equal to negative 3, then I go to negative 3, but because there's a greater than or equal to sign, because there's an equal sign there, that means x could be a negative 3, because it could be greater than or equal to. So we're going to put a solid dot to denote that it is included in that. And x is greater than negative 3, so we're going to shade this direction. That's all you have to do to graph. Next thing is set builder notation. Set builder notation is just a formal way of saying what you already know. So for this first equation, x is smaller